Okay, when you're asked to solve a system of equations using the Gauss-Jordan Elimination method for a 2 by 2 matrix, one of the things you're going to do is you're going to kind of start off by converting this problem into an augmented matrix. So basically, you're going to take your x coordinate and put it here, your y coordinate of your first equation, and what it's equal to over here with the little dashed line. So this is where the augmented part comes in. Okay, and then we just take our coefficients here, 2, 5, and -1, and put them here. This is going to be considered row 1. So we're going to say r sub 1. That's going to, when we see that, we say row 1. And this will be row 2. Now your whole goal of all of this is to, using multiplication and addition, to convert this into something that looks like this. So we want to have a 1 and a 0 here, and a 0 and a 1 here, and then you're going to be left with the answers are going to be over here on this right side. And this is basically, did you notice these are our x coordinates, these are our y coordinates. So when it is in this form, 1, 0, that means x equals a. Okay, and then here for the 0, 1, this is y. 1y equals b. Okay, so what we've done is you're going to manipulate your matrix so that you get something like this, so that you can solve this for x and y. Okay. So let's go ahead and work on this problem. Now, the ALEKS program actually has you solving this in a particular order. Okay. And it kind of gives you hints that what you're doing. So -8, -6, our little dash line here, -2, 2, 5, and -1. So the first goal, we're going to kind of go in this order. We're going to convert this -8 to a 1, and then our next thing is we're going to change this to a 0, and then the next thing we're going to change this, whatever's in this position here. Oops, I realized you probably can't see that. So so we're going to start here with the -8, convert this to a 1, then go to this position here and convert this to a 0, convert the number that's in this position to a 1, and then convert this to a 0. So that's kind of the order that we're going to go in, because that's the ALEKS programs are going to actually want you to fill in each of those values. So what can you multiply this by, -8 by, to make this equal to a 1? Okay, I'm going to just put this up here, so our goal is to make it look like this. Put that here so you can see it. So you can multiply this by an 8, a -1/8, sorry. So a -1/8 times row 1. That's what we're going to do. And that is going to give you, now you have to multiply the whole row 1 by that. So -8 times a -1/8, that gives you a +1. That's what we want there. Okay, and then a -6 times a -1/8, that's going to give us 6/8, which we simplify that to 3/4. And then a -2 times a -1/8, that's going to give you a negative times a negative is positive, 2/8, which becomes 1/4. Now we just leave row 2 just the same way that it is. Okay, so we have now the 1 here. So now our next goal is to get a 0 here. Okay, so if we want a 0 here, we could get a 0 by adding a -2, the opposite of this value, to it. So what we want to do is convert this to be a -2, and then add the two equations, these two rows together. So what do we need to do to this to convert it to a -2? We multiply it by a -2. So this is where you get the -2 times row 1 plus row 2. And we're always taking the information from the last matrix that we did. So I'm going to do that here. So negative 2 times 1 is a negative 2. And then we're going to add it to this value here, 2. So that's how we're going to get this new entry here. Okay, so now we're going to take this a negative 2 times 3/4, and then we have to add it to this row 2 value here. So that's going to be a negative 2 times 3/4 is going to give us a negative 6/4 plus 5. Okay, so now we're going to take a negative 2 times the 1/4. So that's going to be a negative 2/4. I probably should have simplified those, but I'll just write them this time. And then we're going to add that to row 2 value, which is a negative 1. Now we're just going to write down this row 1 just like it is. So it stays the same. So we're not trying to change it. We're going to only just change one thing at a time. Now let's go ahead and simplify this. So negative 2 plus 2, that gives us our 0. That's what we wanted. And then, oops, got to put it in the right spot. So we'll just kind of, let's just write this here to start with. 1 3/4 dash 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 1/4 here. Okay, so negative 2 plus 2 is 0. Now this negative 6/4, that's a negative 3/2. So negative 3/2 plus 5. So just over here, let's just put that over here, is essentially what we're doing. And we can convert 5 to 10 over 2. So let's just write that as 10 over 2, right? Because you can think of 5 as 5 over 1, multiply both of those by 2, it gives you 10 over 2. So that will give us negative 3 plus 10, which is 7/2. Okay, so and this negative 2/4 becomes a negative 1/2. Plus 1, we're going to convert, or plus a negative 1. So a negative 1, we can write that as a negative 2 over 2. And that gives you a negative 3/2. Okay, you can see this is a little bit of a long process, but it'll get faster the more you do it. Okay, so now we see we have our 1 and our 0 here. And then our next thing we're going to do is we want to convert this 7/2 to a 1. So whatever's in this position, remember. So what can you multiply this by to make this into a 1? So you multiply it by its reciprocal, which would be 2 over 7. So this is where we're going to say 2 over 7 times row 2. That's what we're going to do. So let's do that and see what we get. So row 1's going to stay the same. We're not doing anything to it. And so 2/7 times 0 is 0. And then 2/7 times 7 over 2, that gives us 1. And then 2/7 times a negative 3/2. So I'll put that over here for us. 2/7 times a negative 3 over 2. You can see the 2's will simplify. And that gives us a negative 3 over 7. Now we're almost done. So we've got our 1, our 0, or 1. We need to convert this to be 0. Okay? So if we want this to be a 0, we need to add a negative 3/4 to it, which means we need to manipulate this second row here to be a negative 3/4. And we can do that by multiplying. Since this is a 1, it makes it a little easier. We're going to multiply this second row by a negative 3/4. And then we'll add that to row 1. So I'm going to put that up here. We're going to take negative 3/4 times our row 2, we're going to add that to row 1. And that's going to be our new row 1. Okay, so row 2 is going to stay the same, 0, 1, 3/7. Okay, so what we're gonna do here again, we're gonna go back down here to this matrix here, and we're gonna multiply row 2 by a -3/4. So 0 times -3/4 is 0, and then we're gonna add that to the row 1. So we basically have 0 plus 1. Now we're going to take a -3/4 times this y coordinate here. So -3/4 times 1, which is a -3/4. And we're adding it to this row 2 here, which is 3/4. Okay, so now we need to do the same thing, -3/4 times row 2 down here. So that's where we're going to get a -3/4 times a -3/7. And so that's going to give you negative times negative is positive, so that's 9. 4 times 7 is 28. Okay, so 9/28. And we need to add that to row 1, which was 1/4. Okay, now we need to just simplify this. So the bottom part is going to stay 0, 1, and a -3/7. Now this top part gives us a 1. 0 plus 1 is 1. A -3/4 plus 3/4 gives us the 0 we wanted. And then 9/28 plus 1/4. Now, so we can see, hey, if I multiply this 1/4 by 7/7, I get the common denominator of 28 here. So that's going to give me 7/28. And I can add 9 and 7 together to get me 16. 16/28. I can simplify, I can divide both of these by 2, and that's going to give me 8/14. I can keep going, and that gives me 4/7. Okay, so now that it's in this form, this is my x equals 4/7. It's basically saying 1x equals 4/7. And my y value is a -3/7. You can see this is a little bit of a long process, but like I said, the more you do this, the faster you get at it.